Hello, in this video, we will introduce linear search and binary search. Searching is the process of looking for a specific element in the list. The specific element is called a key. There are two ways to search. One is called a linear search. The other is binary search. Linear search is that you're going to search through all the elements until you find it, or you exhaust all the elements, you did not find it. In that case, you're going to return the index value is -1. So the search is to return the index value. So for example, I want to see if this 71 is in the list. So now you perform the search. This is a match. So going to return index is 0. Now, if you search an element, so let's say here 71 again, but 71 is not in this new list, so you're going to return -1. So we're going to write this as very simple. Search is linear search, search the list using the key, and look at for every element, compare it with the key. If there's a match, we're going to return I, that's index for the first matching element. After all the search exhausted, return -1. So this is a simple linear search. Another search is called binary search. This search here is assume all the elements in the list are already sorted. So let's say I have 15 elements, and thus all the 15 elements are sorted. Now I don't have to search from the first to next in this sequential order. I can search from the middle. So look at the middle here, 24 comparing with 38. 24 is less than 38. So now we can search only the first half. So that is the idea. You cut down by half with every comparison. That is very efficient. So provided that this list is already sorted. So how do we implement a binary search? So the way we're going to implement it is to use the index. So I'm going to look at this now, 24 here. Let's do the search. So what do we do is to begin with, this is the index, is the low and the high. So the low is 0 and high is the last one is 14. All right, so here now 24 is less than mid. So this is the mid element here, 38. So now you see I'm going to move high to the index before mid. So that's mid -1. So that is, and continue this search. So we're going to maintain this 3 indices, low, high, and mid. All right, so this is what we're going to do. And we're going to search once. It is this low, high, and the mid is low plus high using the integer division divided by 2. So we're going to compare the key. If key is less than the mid element, so we're going to move high to mid -1. If key is equal to the mid element, and this is going to be returning the mid. So please note that I misspelled this. It should be LST. So else we're going to move low to the index after mid. So this is the version for this one-time search. So we need to continue to search the other half. So now this is put this in a loop. So we're going to put this in while loop. While high is greater than or equal to low, we're going to have this continue. And so if there's a match, you're going to return the index. If there's no match, so what are you going to do? Okay, let's just return -1 means there's no match. But there's a better way to return this negative value. We can return a value that indicates if you wanted to do a search, where you're going to search. So that is, the value is a good indication, and you know where you're going to put the new element into the list. So for this, I'm going to choose this. So if you look at this here, now this is the this is 24 now. Let's continue now. So 24 is greater than 13. So we're going to move low after mid. So it's right here. And now we still need to search. Look at the mid here. 24 is less than 35. So now high is going to be just one before mid. So that is right here. So we're going to compare this now. This is the 24 is greater than 18. So we're going to move the low past the mid. So that is here, low. So what happens, this is the low now, is greater than high. So means you don't have a match now. So in this time, we are going to return negative low -1. That's the value we're going to return. So this will indicate where we're going to insert it. We're going to insert at the low. This is the location we're going to insert. Its low is where we're going to insert it. But when we return value, we don't return -5, because the reason is if this low is right here, 0, and -0 will be still 0. So that's not a good value, because that would be 0 would be a match value. So now I'm going to have this is return is negative low minus low. So let's see here. I'm going to have this, so let's go back to look at this, running this code. So I have this list, and this is 2. So what are you going to return? Yes, the index happens to be 2. So if this is 9, so what you're going to return? This is going to be return 4. If it's -3, you're going to return 0. So now what happens if 5? 5, you are going to insert it right here. So that's going to be -4 minus 1. So it's going to be -5. So if you run this, it's -5 here. So what about 7? 7 is also -5. What about 20? So 20 will be inserted here. So this is the 0, 1, 2, 3, 4, 5. -5 minus 1, that's going to be -6. -6. All right, so that is all for the searching algorithms. We introduced the linear search and binary search. And binary search is more efficient, but you have to assume that the list is already sorted. That is all for this video. Thank you for watching. See you on the next video.